Hi everybody and welcome to the Mangano Digital Academy. In this short lecture I will talk about the accuracy of full arch digital implant impression, and in particular I will focus my attention on this very important aspect here in the number 6, congruence. So the correspondence between the mesh of the scan body and the corresponding library file. The dimensional congruence between these two components, that is very important. It's key for the final position of the implant, so for the final accuracy of the digital implant impression. Obviously, this congruence may depend by other factors, the intraoral scanner, for example, or the scan body itself, for example, the tolerance in the position of the scan body. And all these factors contribute to the final congruence, but the congruence itself should be considered and highlighted because it is a very important factor and it is one key factor in the whole process. Let me, before to focus on the congruence, to summarize a little bit the other factor involved for the final accuracy of digital implant impressions from the clinical point of view. These factors are the intraoral scanner with its intrinsic accuracy and its intrinsic related error, the operator with different skills, different level of experience, and of course the scanning strategy adopted by the operator during the scan. Different kind of strategies may determine different results with different scanner because we have different technology of acquisition and we know very few from the literature on this topic. The patient, it's also important, the number of implants, the inclination of the implant, the depth of the implant, the environmental condition, the light, for example, the temperature. And the scan body. The scan body is not only the transfer of the implant position like it was in the analog impression. It is totally different, it's more, because the design, the material, the tolerance in the manufacturing, in the fabrication, in the production of the scan bodies, as well the position, the torque, may have an influence on the final results. And so the congruence. The congruence is the topic that we address in this specific lecture. So let's address it. Let's talk about the congruence, as I told you. And I will refer to this study that we published this year in 2020 in the Journal of Clinical Medicine, about the congruence between scan body meshes and libraries. Is there a congruence? And how much a lack of congruence can affect the final quality of an implant impression? First of all, let's go back to the basics. Intraoral scanner, they emit a source of light, usually is a structured light, grid or pattern, and or eventually a laser, and then this grid this light impacts on the surface of the scan bodies in this case, and the fully edentulous arch, and the deformation it undergoes is captured by powerful cameras. These cameras send the information to the heart and the brain of the scanner, the software, the acquisition software. The acquisition software create a point cloud. These points are then triangulated into mesh, and then we have a mesh, the surface reconstruction of the scanned object. And this mesh, this polygonal mesh, is always a geometric approximation of that surface. So it's not the object itself, it's an approximation because it's the object schematized into triangles. So obviously we are talking about an approximation, and depending about the number of the triangles and the point cloud, then we can have an approximation that looks like the real object because we have a lot of triangles and our resolution of acquisition is high. But we can have also a low resolution of acquisition in case we have less points and in case we have less triangles. After all, the triangles make the difference. And I would say that probably for the implant prosthodontics application, it's not so important to have so many triangles because we are capturing a position of the implant. We don't care about a margin of a natural tooth that should be instead extremely well defined. So we don't need a high resolution of acquisition, like for example when we design a margin on a natural tooth, because we don't need such kind of resolution. But anyway, resolution can help. But despite of the resolution of acquisition, despite of the high number of triangles, anyway the object is an approximation. The mesh, the polygonal mesh, is an approximation, a geometric approximation of the object. And it's totally different, for example, from a NURBS, non-uniform rational basis spline file, or any library file, because this is another kind of file. They may be saved in standard tessellation language or STL format, both, but they are different, intrinsically different. Why? We see it watching this video, because if you watch we are far and we don't watch in detail, they look similar, the scanbody mesh and the scanbody library file, but if we go at higher magnification, we can see that the mesh is full of triangles. We don't have so well-defined margins. Everything is a result of triangulation, so everything is smoothed a little bit and not so well-defined. So it is important to distinguish between these two kinds of files, because what happens technically at the first early stage of the computer-assisted design, the dental technician receives from the dentist some meshes, so approximation of the arch. It receives usually a master model with a mucosal collar, then the master model with the scanbody, then the antagonist arch and the bite. And inside the master model, it replaces the scanbody mesh with the corresponding library file. That is a file originally designed in CAD, so perfect. Similar to a NURBS file, even if it is not, but it's not important. The point is that it's not a geometric approximation. And this file, this library file, is linked and coupled to all the components of the library that are needed to model our restoration. So T-bases and links and whatever it takes to design a restoration, provisional or definitive. So the technician, after this replacement, can model on an hybrid model, because we are talking about a mesh that has a component, and this component is a library file. And so all the library is designed in CAD with perfect margin, and it makes all the difference. And in this short video, we can see this procedure. That is the first procedure, very important, that the dental technician performs inside a computer-assisted design software. So the dental technician receives the meshes, including the one with the scanbody. They may look well, but anyway they are geometric approximation. And then he select the library, he select the scanbody library file, and through one point it identifies the scanbody mesh on the global mesh, and then the best fit algorithm performs the superimposition. And then after this superimposition, the dental technician can go on with modeling on an hybrid model, because the model is hybrid. The model is a mesh for the teeth, in this case for the wall arch, except that for the library component, the T-base. The T-base is part of the library, and we can choose different kind of inclination, angulation and everything, but anyway we are talking about a library file that is perfect, that is more similar to a NURBS file, but it's not a mesh. So what we wanted to investigate with Dr. Lerner and the group of the University of Moscow in this video, video where we talk about this article in particular, is the congruence between the meshes and library file of implant scanbodies. And it was an in vitro study that we made comparing 5 different scanners. And we used this model prepared by my friend, Master Dental Technician Uli Oshild, representative of a fully edentulous maxilla with 6 implant scanbody. This scanbody are the 13mm scanbody from the Megagen company, from the AnyRidge implants. And the implants were more or less parallel each other in different positions, as you can see. We used 5 intraoral scanners, but also a desktop scanner, because I wanted to investigate also the effect of the desktop scan on the congruence. And the intraoral scanner investigated in this case were PrimeSky by Dentsply Sirona, iTero Elements 5D by Align Technology, CS3700 from Carestream, E500 by Merit, and Emerald S from Planmeca. So these were the scanners, with different technology of acquisition, of course, different characteristics, and also different output file. We basically worked on STL files, so standard tessellation language, for our comparison. What we did in the study is very simple. I captured 10 scans with each one of the intraoral scanners, so same operator, same strategy under the same conditions. Then in all scans using a powerful reverse engineering software, I replaced the library files, and I superimposed the library files onto each one of the scanbody mesh. And then I evaluate, using the powerful tool of the reverse engineering software, the congruence between the library file and the mesh of the scanbodies. So basically, what we did was to capture in total 53 meshes, 53 scans, and per each one of these mesh we made 6 superimposition. Each single scanbody mesh was replaced by the scanbody library file in the correct position, and then we evaluated the congruence, the dimensional congruence between the library file of the scanbody and the mesh of the scanbody. And the evaluation was quantitative, by means of the colorimetric map generated and by means of the tools available in the software, but also qualitative. We wanted to understand if there's a pattern for the different scanner in the creation of the scanbody mesh. And these were the results, the descriptive statistic with the means and standard deviation, median and quartiles. As we can see, we have, and it's immediately evident, we have differences in the congruence with the different scanner, and also we have differences in the congruence with the different scanbodies. It may tells us a little bit about the tolerance of the fabrication of the scanbody, but also it may be related to the position of the scanbody that are in the frontal area. S3 and S4 in particular, they perform worst compared to the other scanbodies, and this may be related also to the position of the scanbodies. If we watch the quantitative evaluation in this graph, we see that the best results in terms of congruence were obtained by CS3700 and PrimeScan. So they were the best scanner in the quantitative evaluation. And it's interesting because the mistakes, the error are comprised between 20 and 30 for these two best scanners. That is per single element. So it may be already a good results if we consider everything, but if we compare the different scanners, we see that there are differences, statistically significant differences between different scanners. So in terms of congruence, so some congruence guarantee a better, some scanner guarantee a better congruence than other scanner. And this is very important, maybe the most important slide of all the study. As we can see here, I collected the best single result per scanner, including the 5 intraoral scanner and also the desktop scanner, that is F, the DOF. Basically, we see that the best results, the best possible result for each scanner among 60 superimposition. So it's the best results among 60 superimposition per each scanner. And we can see here that the PrimeScan has 17 micron of error mean, so the distances are very little, the CS3700 around 20, these are very good results. But we see that there are also patterns. We understand that there are also patterns of deviation because the Carstream scanner behave more or less qualitatively similar to the desktop scanner. As you can see, they're more yellow and red color on the front and on the back of the scan body. What does it mean? It means that basically the mesh of the scan body is wider, is bigger than the library file. So the library file, like in a matryoshka, is inside the mesh. We have in this case a situation in which probably there is a little bit more noise and the noise is not reduced automatically by the acquisition software. So we have a wider mesh even if the congruence is very high for both, because we are talking about 20-21 micron for CS3700 and DOF respectively. For the other scanner, for the iTero elements, for PrimeScan as well, for Emerald S, we have the opposite situation. So we have more blue color and more pale blue. What does it mean? It means that the deviation is inward. It means that actually the mesh is contained inside, after the superimposition, is contained inside the library file. We have a different qualitative pattern after the superimposition, and it's also important. The made-it scanner has a sort of interpolation. We have more green. Please note that the threshold fixed here was very little, so the threshold was a few microns. So we are talking about something very precise, and probably we can get information from this, because probably the acquisition software, we also have a noise here, but the acquisition software of this scanner decide to cut the more external point, and there's a sort of a cleaning process. So the most external points are eliminated automatically, and the scanbody mesh then is embedded, is inside the scanbody library file. The most important thing is the congruence, of course, but the qualitative evaluation is also important. Is we have the absolute deviation across the intraoral scanner and the scanbodies, and once again we see that scanbody 3 and scanbody 4 have the highest deviation, compared at least with scanbody 2 or scanbody 5. They have less deviation for both, almost all the scanners. But we have differences between the different scanners, as we can see in terms of congruence quantitatively. As we can see here, also there are big differences within each group between the different scanbodies. So there are two factors that determine the congruence or not, the scanner and the scanbody. They are the main factor in this case. And as we can see from this table, we have a comparison on the mean absolute deviation between the scanbody within each group of scanner, and here we have the p-values, and as we can see we have statistically significant differences between the different scanbodies within each group. So clearly the scanbody is a factor. Probably there are tolerance in the fabrication of the scanbody. We have investigated it in another lecture, but and in another research. But maybe also the position of the scanbody may play a role. So the scanning strategy may be of some importance in this case. The only thing that looks less important is the model. So the model is not a variable that influences the final results at the end. Only primes can add some deviation between the models. All the other scanners were very stable in the result and consistent, as we can see here. The hierarchical big clustering results are very interesting. Here we can see the two factors together, condensated in one graphical, very nice picture. And we can see that PrimeScan and CS3700 are the more congruent, and exactly with scanbody number 2 and scanbody number 5. Instead, scanbody number 3 and scanbody number 4, particularly with Emerald S, they have the highest level of error. The average absolute deviation is higher, as we can see, until 40 microns and even more. This is too much, probably, for our work. And here the second hierarchical big clustering, grouped based on variability or standard deviation or absolute deviation, tells us more about the stability and the reliability of the scanner, because hetero elements is extremely stable and made it as well, and Emerald as well. So there are less variations among this scanner, even if the congruence is less, apparently, at least in this study. And the qualitative evaluation is also very important, as I have anticipated before. The behavior of the different scanner is different, because CS3700 from Kerastrin behaves a little bit like the desktop scanner. What does it mean? It means that the mesh of the scanbody is bigger, is wider than the library file of the scanbody. So the library file of the scanbody is embedded, is included inside the mesh. Like a matryoshka, there's a tendency, a clear pattern in this direction. And it's typical of desktop scanner, and we see it when the acquisition software doesn't clean completely the noise around the scanbody during the acquisition. We see this situation in the desktop scanner usually because there's a lot of light, and with the CS3700 apparently we have this effect that we don't have, for instance, with the other scanner, because in the other scanner we see the opposite situation, as I have anticipated before. So we have the scanbody mesh that is included in the inside the library file of the scanbody, because the library file of the scanbody is bigger. So this is something very clear, and a clear tendency, a clear pattern for hetero elements, for prime scan, despite of the high congruence, and also for the Emerald S. For MEDIT, we see that there's a sort of interpolation between the different entities. So what does it mean? It means that probably in the prime scan, in hetero elements, in Emerald S, the acquisition software clean more the point cloud around the scanbody during the acquisition. For this reason, the mesh of the scanbody results to be a little bit more little in this case when compared to the reference file. Anyway, I think it would be very easy to have the dental technician during the superimposition. Pose that the dental technician need to control the superimposition with the tools he or she has, because inside hexagon, inside tree shape, inside dental width, there are colorimetric marks that help to understand the quality, the level of quality of the superimposition. So if the dental technician use these tools, it's already something very nice. The less mistakes we have in this moment, the best is the final fit of the prosthesis, so it's key. And it would be very nice to have different, type of scanbody with incremental percentages. For example, the scanbody 0%, and then the scanbody 0.1% increment, 0.2% increment, and as well, and decrements, because this could help to have a the best superimposition possible. But it's only one idea. I see that implant companies are not using it, and they don't pursue this. They don't do it, but it would be great to have the dental technician to have the best superimposition, because the best superimposition means the best congruence, means the perfect implant position. So the perfect transfer of the implant position into the working model. So it's very important. Not only the quantitative side, but the qualitative side may help us a lot. The conclusion of this study, it's a very complex study, I have to say. It's the first study that addressed this topic of the dimensional congruence between the meshes of the scanbody and the corresponding library file. We found different level of congruences among different scanners. The best results were obtained by PrimeScan and CS3700. I have to say that also we found different level of congruences among different scan bodies, and this may be related to some tolerances in the fabrication of the scan body, or even more probable, it could be related to the position of the scan bodies, because we found that the scan bodies in the anterior area were the most prone to lack of congruence for some reason. The models instead didn't reveal any differences among the different groups. I mean, inside each group there were no statistically significant difference between the models. So the model is not probably the element. The key element are the scanners used, and of course the scan bodies. And we also found not only we also evaluated the results not only quantitatively but also qualitatively, and we found different patterns for the different scanners. And we found a peculiar pattern for the CS3700 where the mesh usually is bigger than the library file. This happens with the desktop scanners, as confirmed in this study. This never happens with the intraoral scanner. It is not a problem itself. The way to potentiate this superimposition, to give more tool to the dental technician, would be very easy. It is sufficient to provide, the implant company should provide a 0% and then a 0.1 or 2% increment of the scan body in order to facilitate the dental technician to perform the best superimposition. After the superimposition, the position of the implant is correct, and the technician can work very well. This is the paper, actually. It's available in the Journal of Clinical Medicine, so it is possible to download it for free because it is an open access, a Q1 journal with a very high impact factor, and you can go to the website of the Journal of Clinical Medicine and you can download it very easily. I invite you to watch our website, the website of the Mangano Digital Academy, because here you can find all the information about our courses, our researches. You can follow us in YouTube, Facebook, Instagram and Twitter, and we use a lot of different devices, we use a lot of different software. There are software and devices that we love and listed here, and we have a lot of research projects ongoing, and we really want to deal with digital dentistry more and more because it's the future of dentistry. Thank you very much for your kind attention.